Welcome back. Today we are looking at National 5 Maths Applications Unit, Outcome 1.1, looking specifically at the area of a triangle calculated using trig, the cosine rule, and the sine rule, which all three of those come directly from our National 5 formula sheet, which means no memorizing formulas for this outcome, and each of these questions can then be solved on our past papers ready for the exam. So let's jump straight into question 1. Now, question 1 says that Paul wishes to sow flower seeds in a triangular plot of ground. The diagram gives the dimensions of the plot. Calculate the area of this plot. Well, area of a triangle, pull the formula straight from our formula list. It says that A is equal to 1/2 AB sine C. And we should remember that when we are labeling our triangle with trig, if this is our angle C, then our other two angles A and B give us our sides. Remember that the lowercase side is opposite the uppercase angle. So there's A, there's B, and here's little c. And so now we have all the numbers we need, giving us that A is equal to 1/2 times 7.3 times 9 times sine of 62. And we can pop that directly into our calculator, all in one line, remembering that we can use 0.5 for a half, and times 7.3 times 9 times sine 62, making sure that your calculator is in degrees mode. Hit equals, giving us, in this case, the answer 29.004 ... degrees, or rounding to three significant figures, 29.0, sorry, that's not degrees at all, 29.0 meters squared, because this is an area. That's question 1. Question 2. Two boats, A and B, leave the harbor H at the same time. Boat A travels for 4 kilometers, boat B for 5.7 kilometers. The angle between the boats is 32 degrees. What is the shortest distance between the boats? So what we have here is a triangle where we know two sides and the angle between them, and we are searching for a third side. When we're looking for a third side, or we have all three sides and we want an angle, we can use the cosine rule. Now I'm only taking the side portion of this formula. On the formula sheet you are given the rearrangement for calculating an angle, but we don't need that just now. So what is the shortest distance between the boats? The shortest distance between any 2 points is a straight line. We are looking for this side here, which I'm just going to label A for the purposes of our formula. I'm going to label the other two B and C, not worrying too much about our angles, just to keep it right in my with my calculations, giving me our angle A over here, so that we can see where each of our numbers is going to come from. So using our cosine rule, we've got a squared equals b squared plus c squared minus 2bc cos a. Filling in our numbers then, we have that a squared is equal to 5.7 squared plus 4 squared minus 2 times 5.7 times 4 times cos a. Move that a little bit more in the middle. Now, rather than put all of that into my calculator and then take the square root of it, I'm going to do that in a single line. So what I'm actually going to put into my calculator is a directly. I'm going to say a is the square root of 5.7 squared plus 4 squared minus 2 brackets 5.7, close the bracket, open 4, close the bracket, cos, and a was 32 degrees. I should have written that in earlier. All of our numbers are in place. Be careful of your brackets when you're typing this into your calculator. On mine, I've got the square root, and I'm going to open a bracket. I can press 5.7 squared plus 4 squared minus 2 times 5.7 times 4 times, and then my cos does not open a bracket for me, but Casio calculators do. So I'm going to say 32. Then I'm going to close my bracket, and that closes it behind here. That's like having a nice big bracket here and a nice big bracket here in my calculator. And when I press equals, I get an answer of 3.133 dot dot dot, or to three significant figures, A is equal to 3.13 kilometers. Distance between the two boats. That's on our diagram, this side here. Carrying on to question 3 and the final question for this. A helicopter, H, is due north of Fraserburgh and 70 miles from Aberdeen. So here's my helicopter, and it's due north of Fraserburgh. So if we go head south from the helicopter, we get to Fraserburgh here. And it is 70 miles from Aberdeen, which is over here. The distance between Fraserburgh and Aberdeen is 42 miles, this size here. The helicopter wants to fly directly to Aberdeen. Calculate the bearing the helicopter needs to fly on. So, our helicopter wants to travel directly from H to A. That's that distance here of 70 miles. And it needs a bearing. Now, a bearing, remember, is an angle measured clockwise from north. It's this angle here, as if it was facing north and then it turns to face Aberdeen. We want that bearing, and I'm going to label it X for just now. Now, with the information we've got, we actually have a nice triangle here where we have the pair F and little f, and we want this angle here inside here, this capital H, because we have the side here, little h. We have two pairs that we're going to be working with, which would use our sine rule. Now, if I pop in my numbers here, what I have is 70 over sine 110, that's my f and little f, is equal to my little h, 42, over sine of h. That's the angle of the helicopter in here. Remember, we are working out this blue angle in here at the moment. Now, I'm going to cross multiply these to get rid of these fractions, and I'll have that 70 sine h is equal to 42 sine 110, giving me that sine h is 42 sine 110 over 70. That's just dividing through by 70 to get rid of that. And before I get to my calculator, I'm going to say that h is the inverse sine of that above bit there, 42 sine 110 over 70, giving me a h, popping that into my calculator, inverse sine, open my bracket, 42 times sine of 110, and again, be careful with your brackets on these. Divide that all by 70 and close my big bracket. Gives me a h of 34.32 dot dot dot, which I'm going to reach is equal to 34 degrees. Now that will get me the majority of my marks, but I'm not actually finished yet. What I now have up here is that h is equal to 34 degrees. See from our calculations there. But what I actually want is my bearing, the bearing x. And since we know that Fraserburgh is due south of the helicopter, that means that this line here is a straight line. That line there is a straight line pointing from south right up to north. Now, since we know that that is a straight line, that means that the angles across the straight line add up to 180. So my bearing x is going to be 180 minus the 34 degrees I calculated. So my x is going to be 146 degrees. It doesn't matter so much in this answer, but bearing should always be 3 digits. So there you have it. There is my bearing of 146 degrees. I'll just show you the whole page there so you can see all of the working at once. Now, if you have any questions with this, please leave them in the comments or contact me on MrGoanMaths@gmail.com. Good luck in your tests.